Hello, this is Ryan Woodward recording for Intel's Digital Logic course. This is Lab 3 Part 1, but this is the actual correct video, correct code. Although I never actually got the code to work, at least in the sense that if I were to program the FPGA, I could see all of the intermediate signals as inputs and outputs and interact with them. That was what I was hoping for, but that's not exactly what is designed to happen here. What we actually see with this signal and these attribute keeps here is that we're actually able to visualize these when we use, say, the RTL viewer or other test bench tools in Quartus itself. And that's what I want to show and just go through briefly in this video, is to share the code and then actually share the images that I took screenshots of as I put this through the testing for this lab. I won't include a demo for this one because, as I said earlier, I couldn't get the FPGA to recognize all of the ports or the intermediate signals to represent inputs and outputs, understandably though. But briefly, we can just go through their code a bit. As they mention in the lab document, this attribute keep here allows us to use these signals as separate signals in the code and in the testing. So for instance, if I'll pull this file over here, we can see this from the RTL viewer. We see these independent signals RG, SG, QB, QA, for instance. These are treated as independent signals, and that's what that attribute keep does, that directive that actually does. But for instance, we can also see in these memory elements, they are preserved here as well. We see SG, RG, QA, QB, and so on. They're broken up into these independent elements here. Excuse me. And finally, here is the test bench, and we can observe the same exact results from the lab in that their test scheme or their simulation, the waveform that they have in that document. But this is the one I took showing the test bench simulations that we had to use. And the test bench code, I believe, is in the lab files on fpgaacademy.com in case you're looking for them. But this is the results of that. And honestly, that's it. There's not much more to go through just to show the results of testing out the circuit. It works as properly, even though we don't really get to program the FPGA with all of these intermediate signals. For instance, to get that 3 memory element LUT, 3 LUT version of the SR latch itself. So instead of having actually an SR latch that allows us to see and output all those signals on the FPGA, we don't do that for this lab, or at least this part of the lab. And so that's where I'm at. I just wanted to share this brief update for part 1. Thank you.